Note that even those events or properties that in principle we can observe directly, like the acidity or temperature, in science we often prefer an indirect observational process. So we don't measure the comparative speed of cars with our eyes standing at the goalpost, but rather we use a timer and a distance measure. We use thermometers of different kinds for the measurement of temperature, and we use pH indicators for acidity. In each of these cases, we are now relying on a more involved process for which we do have, or believe we have, justification in terms of justified theories or models. Why do we do that? Even in those cases where in principle we could rely on direct observation. Now, well, it's two reasons. The first is that our direct observations often are unreliable. So there are plenty of cases where we can show that our direct observation give us wrong results. For example, length perception varies with distance, or height perception varies with distance, or loudness perception varies with background noise. So it's not very reliable to have people use their ears to make comparative judgment of loudness. Instead, it's much better that you use an instrument that picks up on some effect of noise and then displays that in an indirect fashion. Furthermore, and we'll discuss that later, direct observation typically only gives qualitative properties, right? So when I argued that temperature and acidity in principle can be directly observed, it was also clear that we could at best get sort of a ranking, a comparative ranking, but we wouldn't be able to say much about, for example, distances between different measurements because we cannot quantify. So instead, we need an indirect observational process for that. And that we get when we are operationalizing. So we operationalize a property of interest by providing a way of linking it to a directly observable effect. And this goes two ways. So we have the property of interest. We have some effect that we can directly observe. And then we are linking that through typically a causal, but sometimes we might also just have a correlational relationship that must be sufficiently reliable. And if that's the case, then we can go the other way in our inference. That is, we are observing the effect, and then because we've hypothesized that the relationship, we are able to infer that the property was present or absent or was there to a certain degree. So here are the examples, some of that I've already discussed. So with temperature, we're interested in measuring temperature. We are hypothesizing a linear relationship between liquid density and temperature, and then we are observing changes in liquid density. With attitudes, beliefs, or desires in humans, we are assuming a relationship between the presence or absence of certain of these attitudes and the way how people answer in questionnaires. And then we take those questionnaires as giving an indication of these attitudes. This can also go wrong, right? So you can operationalize in a way that is not good, that actually fails in important ways. So here's an example that we are actually quite used to. You're interested in the mass of an object, and then you're using a spring scale, the changes on the spring scale, in order to indicate the mass. Note that on this spring scale, in fact, on the left side, it says kilogram. So this is even imprinted on this this device. It claims that it indicates mass. However, what's the relationship here that is required? Well, that there is a direct proportionality between the mass of an object and the gravitational force exerted on that object. And that clearly isn't always given. So that spring scale goes terribly wrong if you use it on the moon. That spring scale goes also terribly wrong if you move it in any accelerating environment, right? So those are cases where it doesn't work. Still, for the marketplace or for you weighing your luggage before you go to the airport, that's fine. Sort of, it works in certain areas, but you must be careful not to expand it beyond those areas, because that's where this relationship here in the middle does not hold anymore. Or take the measurement of people's voting decisions. You're interested in how an election will turn out, so you'll ask people about their intended voting behavior, and you're assuming that between this observable response to a pollster and their true voting decisions, there is a regular relationship. That is, people truthfully answer or express their voting decisions in public. I mean, pollsters have applied this operationalization to great damage in very important recent elections, like the U.S. Presidential election, like the Brexit referendum. In those cases, a lot of people were clearly not willing to express and reveal their intended genuine voter behavior. They said one thing, they voted in a different way. So operationalization here again failed. Why? Well, because people might not be willing to express that to pollsters who they feel might shame them in some way, or they feel embarrassed about their voting decisions, and so on. So we can now see, because operationalizations fail, and they often fail, that we need to specify a number of quality criteria for operationalizations. And here are some. So we can follow this sort of very simple scheme, and we can say that in the first place, we need to properly define what the property of interest is. So we had this very correct commentary earlier on. Well, what do you mean by happiness? We might mean different things, and if we disagree on that, then of course we will operationalize that in different ways, and everything else might be perfectly right about the operationalizations, and still we're ending up with measuring different stuff. And that would be a problem. Then we must have a valid relationship between the property and the effect. We must, according to our best knowledge, it must actually be the case that the effect, the directly observable property, shows up only when the target property is present, and it always shows up when the target property is present. Right? And they are not. And furthermore, beyond that relationship, we also must be sure that there are not too many disturbing factors involved, like in the spring scale. Where we would say, well, for many purposes, that doesn't work because there are just too many factors that might disturb this proportionality between mass and the behavior of the spring scale. So that's what I mean by sufficient stability for the purposes at hand. We must have stability in the light of changing background conditions. And last, we better pick some property that actually is publicly observable with sufficient precision. We don't want to sort of operationalize, spend a lot of effort into crafting such an operationalization when at the end we are ending with a property that is actually still difficult to observe, or that other people can't observe, or that cannot be observed with sufficient precision. All of these are important features for making a good operationalization. Now, let me caution you, because some of you might have heard of this program of operationalism. And operationalism is a particular view of what operationalizations can and should do, but that does not coincide with the criteria of good operationalizations that I've given you here. So, according to operationalism, all concepts, the basic concepts, the definitions or the concepts or the properties that we're aiming to measure, they are actually defined through the operations by which we aim to measure them. So one example would be behaviorism in psychology. The idea that, well, whatever we might call an emotional state really is nothing but the conditioned response to certain stimuli. So happiness is the smile. That's a very radical form of behaviorism that today few people agree on. But you can, of course, also apply this to the natural science concepts. Very simple. Length, the property of length is that which is measured with a ruler, for example. So if you ask, well, what do you mean by length? Then you point to the ruler or the standard meter, and you say, well, whatever sort of operations you perform with that ruler and the results you get, that's what we mean by length. And I think that's a problem. That's different from how things should go. Recall that I argued that you should independently define the property or concept, the target property that you're interested in. Not through the operationalization. You should first say what you mean by happiness or by temperature. Like today we would say temperature is mean kinetic energy. And once we've defined it that way, then we have a whole lot of different operations open up, ways how we can connect that to a number of directly observable properties. And we don't say temperature is what we measure with a mercury thermometer. And why is that? Why should we not do it in the way how the operationalist says it is? Well, in the first place, we want to have more universal. We're thinking of, I think in science, of our target properties in a much more universal way than the operationalists suggest. So the operationalists would suggest that, well, if you measure length or temperature in different ways, then in fact these are different concepts. So temperature measured with a mercury thermometer is not the same as temperature measured with resistance measure. Or length measured on the nanoscale with particular operations is not the same as length measured between galaxies, measured in very different operations. But I think it's intuitive to say that no, we have one concept of length or one concept of distance. And it doesn't break into different concepts depending on how we're measuring it. So that's the first argument. The second argument is that only if we insist on such a more universal, independently defined concept, then we get another handle at criticizing certain operationalizations. So if we agree on what happiness is, then we have a much better handle on criticizing certain ways how to measure happiness than if we go the operationalist way. Because the operationalist can always say, well, okay, so you measure it that way. That's just a different concept of happiness you're measuring. And then we have this multitude of happiness concepts that we're all operating with, and we don't even have a comparison. We can't say, okay, so my questionnaire is different from your questionnaire, or your way of, let's say, evaluating facial expressions, in such a way that, in fact, we're measuring different concepts. No, we're aiming at the same thing, at happiness. We're just doing it in different ways. And it's very informative to know that when we're doing it in different ways, we might end up with the same results, and we can say, great, seems like we're getting at the same property here. And if we don't get the same result, then we might have some extra room for rethinking of how we should operationalize. So, summarize here. Indirect observation require operationalizations, and scientists, even in those cases where we have direct possibilities of directly observing, often prefer operationalizing these properties nevertheless. And I've given you a number of quality criteria for operationalizations and argued in particular that operationalism is not a way how to improve operationalization.